shirt worried about fire. We'll talk about what we found and how fire frequency varies for different land uses and land types in our study area, and then just see what we can learn from this, bringing it all together. So Australian savannas and savannas globally are well adapted to fire. Our savannas have been burning since before Indigenous settlement, after Indigenous settlement. They're still burning now, but the way they're burning has changed, and it's changed in different ways in different places. And that's important because fire has an important role in lots of things, but also in the structure and function of our savannas. One thing that we're interested in is woody thickening. So these are some photos from our research station in the Victoria River District, Kidman Springs, 1973 and 1989. There's been an increase in woody cover. Dave Gillison and Les Searle, they collected some information from aerial photography between 1950s and 2000. Again, sites across the VRD and Kimberley, they found an increase in woody cover on those stations. Why are we worried about woody cover? Trees aren't bad. We like trees, but if you get too many trees, you can actually change from an open grassy woodland to a closed forest. And if you're trying to grow cattle, there's no grass. So we're after a happy balance. But it's not only woody thickening that's been happening. This is just 50 kilometres north of Kidman Springs in Jasper Gorge. These photos are from Darryl Lewis's Slower Than the Eye Can See. And here we've actually had woody thinning occurring, probably because of too much fire. So too much fire, we've heard many times this week, causes declines in fire-sensitive plants. It's been implicated in mammal and bird declines and enhanced greenhouse gas emissions. We've been interested in fire for quite some time. We've got a long-term fire experiment on Kidman Springs, been going since 1993, 21 years last year. And what we found, trying to find the optimal fire management for maintaining a woody balance, but also having good pasture composition in the graze context, was that the optimal fire was 4 years, every 4 years, but late in the dry season. So this is contrary to what we've been hearing elsewhere. We also didn't know what was the fire frequency on pastoral land, so we needed some context for our results, and it was in contrast to what's being recommended on other land that's burning too much. And so we thought, right, we really need to get a better handle on what's going on in the VRD in relation to fire. So this is the Victoria River region. This is where it is in relation to Darwin. It's 132 square k's. This is Kidman Springs, our research station, where we've got our long-term fire experiment. You can see it's this big sea of blue pastoral leases in the region, but there's other land uses as well. We've got the pink defence land, green national parks, yellow Indigenous land, and the orange land is Indigenous land that's also used for grazing. So we decided to have a look at the NAFI fire frequency data between 1997 and 2010. We looked at fire frequency over the entire year as well as just late in the drought season. We looked at how that varied for the different land uses in the region and also some broad land type categories. And so the land types are based on grazing value. The high grazing value land type will be your black soils, your vertisols. Moderate is your red earths and similar productivity soil types. And the low grazing land types will be ones, your sand plains with spinifex, lithosols, rocky escarpments with spinifex, areas that, although grow lots of grass, are not high value grazing for cattle and often actually aren't grazed, even if they are on pastoral leases. So generally speaking, you can expect there'll be more fire where there's more rain because there's more fuel. And we can see in the, this is the 2000 to 2014 fire frequency map for the region. This is less fire through to more fire. So you can see this is 1,000 mil rainfall up here down to 500 mils down here. And straight away you can see there is more fire where it's wetter. But it's not the only thing going on. We've got a lot of fire over here in this pastoral area. And we've got this kind of U-shape of less fire. And without doing a GIS analysis, it kind of does look like it might be related to that pastoral area there. So what did we find when we did the sums? So this table here shows the average fire frequency for the different land uses in the region. And Defence and Park had the highest total yearly fire frequency. Pastoral had the lowest, but that was across the entire year. If we look at late in the dry season, Defence and Park, although they actually have the highest fire frequency, they have a much lower proportion that's late in the dry season compared to the other land uses. This suggests that perhaps they're implementing early dry season fire already to try and prevent late season fires. But that's just the average over the entire land use. There's actually a lot going on within each land use. This graph here shows the proportion of the total area, and on the bottom axis is the frequency of fires. So we can see here for parks and defence land, they've got a much greater proportion of their total area that has more than 1 in 3 year fire frequency. In contrast, Indigenous pastoral and pastoral have a greater proportion of their area that have no fires or only 1 or 2 fires. So why is it that we're getting this different fire frequency for the different land uses? Is it perhaps because they've got a different land type composition? This graph here shows the breakdown of the broad land types within the different land uses. And straight up you can see that Defence, National Park, Indigenous land use areas have a much higher proportion of the low grazing value land type, whereas pastoral has a higher proportion of the best grazing value land type. So we looked at the fire frequency for the different land types in the different land uses. Each of these graphs is a different land use. On this axis we've got the proportion of the area. On this axis we've got the number of fires that occurred in 14 years. And the different lines are the different land types. So the blue is the high value grazing land type, the black soils. The green is the moderate grazing value land, and then the red dashed line is the low grazing value land type. And what you can see here is for defence and parks, those lines are completely overlapping, so there's no difference in fire frequency distribution for those different land types on those land uses. But for pastoral land, it's quite a different story. The highest productivity land type is much more likely to have 0, 1 or 2 fires, followed by the moderate grazing value land type has a bit more higher frequency fire, whereas the low grazing value land type on pastoral land has the same fire frequency as the other non-grazed land uses. So on average for pastoral land, the high value grazing land only burnt once every 10 years on average. The moderate grazing value land burnt once every 5 years, whereas the low grazing value land that's probably not being grazed on pastoral leases was burning just as often as national parks and defence land and Indigenous land. So we haven't done a thorough analysis of why this is, but I've got some pretty good ideas. And I think that with this high grazing value land, one, producers are protecting it from fire because it's useful, they need it for their cattle. 2, they've got more infrastructure in there, so they've got more fences, they've got more waters, and there's more grazing. So there's less fuel and there's more barriers to fire if they do start. So what does this mean? On pastoral land, we found that 89% of the best grazing value land and 73% of the moderate productivity pastoral land burnt less frequently than the 1 in 4 years that our fire experiment has told us is needed to manage woody cover in that region. So they'll actually be having increased woody cover as a result of that. They need more late, hot, dry fires to manage woody cover. Ungrazed land, and in this I include the low productivity grazing value land on pastoral leases. The current fire frequencies are often high, and here there may be the opportunity to reduce fire frequency, maybe implementing early dry season fires, reducing greenhouse gas emissions, getting your biodiversity benefits, participating in savanna burning projects, perhaps getting an income stream to help offset the cost of implementing better fire management. So in summary, fire incidence frequency, it varied a lot across the landscape. This variation in fire history may actually help to explain the contrasting trajectories that we see in the region in woody cover change over time. There is no one fire fits all, certainly for the Victoria River region, and it'll probably be another similar but different story for other regions as well. The optimum fire management varies with land use and land type. And importantly for us in the pastoral industry, we found that applying early fire in a grazed landscape context led to woody thickening and a decline in pasture composition. And this was because we had higher post-fire grazing for a longer period when we burnt early in the dry season because cattle can access those burnt areas. So if you are going to be applying early dry season fire in the grazed context, you probably really need to be looking at managing post-fire grazing, but you need to look at and think about woody cover thickening because that can also be a result of that. Thank you.
Thank you very much. Nice presentation, but I just wondered about the fire frequency depending on lightning strikes, please.
Yeah, I didn't look at that, but certainly on pastoral land, when you've got late dry season fires, they will often be either coming off other land or they'll be started by fire, by lightning. Yeah, but we didn't actually look at that.
Sorry, is there a trade-off with any pastoral stations going into that savanna burning model for reducing greenhouse gases, and is there a trade-off with grazing values from that?
Yeah, so there are pastoral properties thinking about this, but they'll be thinking about that so a lot of properties, they'll have some really productive areas, but they might have some back paddocks that they don't use. Those back paddocks are burning frequently sometimes, and that's the area of their property that they would have a savanna burning project in, because if they're trying to apply the savanna burning project in the other part of their land, well, for one, it's not burning anyway, so it's not going to be relevant. Two, it actually needs more fire. And three, they want the fuel to graze. So, yeah, so, I mean, if they want to apply fire to manage woody thickening, then they might need to actually spell it. Yep. But they're definitely trade-offs. We did some economic modelling of implementing early dry fire in the grazed context, bioeconomic, and we found that, there was a real cost to doing that just because your landscape increases in woodiness and becomes less productive over time.
I think we'll leave it there. So thanks, Robyn, and thanks very much for stepping in at such short notice.